Good morning or good afternoon, everyone, and welcome to our webinar on 3D generative design for AEC. My name is Anne Kozikfriend, and I'm very pleased to introduce this webinar today. Jonathan Asher, who is the CATIA AEC Portfolio Director, will present a web application implemented on the 3D Experience platform for AEC users. Nicolas Senemo, who is working in Dassault Systems too, as an AEC consultant dedicated to cloud users, will then explain a demonstration. As usual, please note that you will receive a link before the end of the week, allowing you to watch the recording of the webinar and send it to interested colleagues. At the end of this presentation, there will be a Q&A session. Thank you to everyone who sent us questions. Jonathan and Nicolas will answer a few of them at the end of this presentation, and we will answer the rest of them in the CATIA user community with the publication of the webinar recording. I hand over to Jonathan now and wish you a very interesting webinar.
Thank you, Anne. My name is Jonathan Asher. I am an architect by training, and I've been with Dassault Systems for 3 years now. And I'm going to show you the very exciting new solutions that we're creating for the architecture, engineering, and construction industries. We're going to talk today about the 3D Generative Innovator role, which is primary application within that role is the CATIA X Generative Design application, a revolutionary new web application that runs on the 3D Experience platform. Our intent with this application is to bring complex algorithmic design processes to the greatest audience possible and democratize this new algorithmic and computational design approach. Whether you're doing scenography, furniture, or interior architecture, all the way through site design, urban planning, and large infrastructural projects, we're bringing this new design inspired by nature approach to any range of scales and users. So to do this, we've created X Generative Design, which is a new intuitive algorithmic modeling approach that's available anywhere, anytime, on any device. Because all of the computation runs on a remote server that we host up in the cloud, you can access this application from any device and be sure to receive the same performance regardless of device size or computation power from any web browser. Some of the basics about this application is that it's included inside the 3D Generative Innovator role, which is an extension that sits on top of the 3D Innovator role. The 3D Innovator role's primary application is X Design, which is another web-based application for feature modeling of surfaces or volumes or solids. Those two roles sit on top of the 3D Experience platform, Business Innovation and Industry Innovation role. This package is delivered together as one package for our users in the AEC industry. So what is X Generative Design? Well, it's a web application that allows you to explore complex, repetitive, or non-regular shapes and patterns using an intuitive algorithmic approach. Whether you're modeling with 3D operators or you're designing in a graphical scripting interface, it's the same unique experience across both user interfaces. And I'd like to give you a brief introduction, but rather than me speak over this video, I'm going to let the experts do the talking. X Generative Design is a revolutionary 3D generative modeling web-based application that does not require any software installation. All computation is made on a remote server. All data is continuously up to date on the cloud. So you can retrieve your model even if you lose your internet connection, even if you reconnect on a different device. geometrical operators are able to work on collections of objects. So when you divide a line, curve, or surface, you get a list of points. You can immediately reuse this list of items to build additional lists of items, including points, planes, and surfaces. The planes generated here are used as support for polygons. That you can access one by one. Important driving parameters, like the number of edges, for example, can be identified during the design process and broadcast as global parameters to be used elsewhere in the model. Relationships within the model can be used to control the geometrical operators. Here, the radius of the polygon is computed using a distance to a reference point. With immediate visual feedback as you modify the position of the reference point. And can be further adjusted with a formula. To have a global view of the dependencies between the collections of objects, parameters, and operators within your model, you can switch to a graphical view of your design. And continue modeling with nodes representing operations whose inputs and outputs are easily connected to each other. In this example, a list of angles is created to rotate every polygon gradually around a central axis. A parameter can be extracted, renamed, and broadcast as a global parameter, which will be accessible from the controller's panel. Groups of nodes can be organized into regions for clarity. There are multiple tools within the graphical scripting environment to organize your models, including regions and automatic layouts. At any point, you can switch back to the 3D environment and continue modeling. Here we broadcast another global parameter. And finally, access the dedicated controller panel, where you can explore different configurations of your global parameters to fine-tune your model and explore variations within a design space. As you can see, we're very excited by the new X Generative Design application. To give it a little bit of context, here you see where the 3D Generative Innovator role finds itself within the greater portfolio of AEC-specific roles on the 3D Experience platform and CATIA. It's primarily as a design tool in the beginning, and it sits next to the Concept Building Designer role or the Civil Engineering role for infrastructure projects, and then can be extended further in the rich client using the Architectural Detail Designer role, the Building Structures Designer role, or the 3D MEP Designer role to do detailed engineering of a construction project. Looking at a typical architectural project within an office, this mapping is our role portfolio across different project types, different project levels of development and complexity across multiple phases. So if you look at a project in concept design, a cross-section of users using the CATIA 3D Experience platform would be operating primarily with the 3D Generative Innovator role, the Concept Building Designer role, and Draft Site for 2D. As the level of development increases through schematic design, design development, and construction, you see that the roles required to deliver the project change over time. Once you get up to level of detail 300, then you're going to be using the concept building designer with the architectural detail designer to do solid modeling for manufacturing, 3D generative innovator role for some of those more complex parts, and the template designer to do advanced scripting and creation of reusable PLM templates across your project. As you get into the operations phases to build level of detail 500 models, for facilities management, you're going to need big PLM assemblies with solid modeling, and the need for more robust CATIA modeling is going to be delivered through the more detail-oriented roles. But back to X Generative Design, our main focus in the beginning is on architects, engineers, and fabricators. To allow architects to explore building designs within a given design space, to allow engineers to imagine innovative solutions to design challenges, and to allow fabricators to create more efficient and adaptive components to improve efficiencies across their workflows. The key values of X Generative Design are primarily to allow users to model any type of complexity, any type of advanced wireframe surface geometry with a high level of automation. We're trying to bring automation to every user, regardless of phase or project type. We're also trying to make generative design processes and techniques available to any designer, maker, freelancer, architect, engineer, fabricator, etc. It's really bringing this, what was an advanced and complicated design approach, to a user of any skill level. So first and foremost, the key differentiator and the key value of X Generative Design is it's on the platform. It's on the 3D Experience platform that shares one common data model and one common collaboration environment across our entire application portfolio. We have digital applications and a data model-centric approach where information is not moved or repurposed. It's all based on the same database in the cloud and allows access to any user at any time. The other key differentiator for this application is that it's one solution for beginners to advanced users. And as a beginner, you can learn these new processes in a way that allows for to easily move from an entry-level user to a more advanced user. By combining 3D modeling, generative 3D modeling, with this graph-based visual scripting, you can go from a low skill level to a high skill level much faster than had you entered into a computational design process immediately into this graphical scripting environment. So we want to, with X Generative Design, accelerate the learning curve to go from a beginner to advanced in as short a time as possible. We're also trying to bring automation to a wider audience. So what is visual coding? It's a means for automation, a graphical way to automate design and generation of data and geometry. X Generative Design simplifies visual coding. You see on the right video here that as you model in 3D, X Generative Design is automatically creating that graphical script for you so that you don't have to go through and work only on the 2D and the 2D graph, but you can model in 3D, and we're generating automatically that script for you. Moreover, you can take those graphical scripts, you can capture them and encapsulate them into templates that can be reused and shared across your enterprise, creating these design patterns that are accessible and reusable to capitalize on your intellectual property and your knowledge and know-how. X-generative design is also a way to generate both simple and complex shapes and patterns. Right? You have access to a wide range of wireframe and surface geometry, volume geometry that allows you to do booleans and other other volumetric geometric operators. You can generate multiple geometries with these operators to create collections of geometry that are manipulated either as a group or individually. In dealing with lists and collections, by generating these massive amounts of geometry and data, you're able to amplify your design process by attacking or approaching a design problem from a different perspective. You're no longer going to be creating one-off models, one-off solutions to a given design problem, but now you're going to approach this design problem in a way that allows you to create these generative models to explore variation within a design space. So rather than create monolithic models, you create models that perform and that can vary. These alternatives can be created and cataloged using the controllers panel, a dedicated interface that collects the driving parameters from your model and are easily accessible to explore design variation within the design space. Because you're generating lots of geometry and lots of data, you're also going to improve decision making by now beginning to approach a design problem with a data first mindset. So that data-driven design is going to improve decision making and allow you to explore more variation and create and explore trade-off studies based on the outputs of your generative model. Harnessing the power of XDesign and CATIA, you'll be able to collaborate efficiently by creating assemblies of models and allowing users to model within the same master model, within the same assembly at any point, and sharing control and driver parameters across all of these different assemblies so that the model is always in sync and the dependencies between models are kept. This reduces complexity of some of those graphical scripts and models that are being created, and also allows multiple teammates to collaborate at the same time. Harnessing the CATIA geometric kernel, you have access to the world's best geometry. With XGenerative design, you are modeling with exact geometry that is second to none. We don't generate tessellated geometry, distorted geometry. Every operator creates exact geometry that is reusable across our entire portfolio of applications. We also, with XGenerative design, because of this, allow for digital continuity across all of our applications that can, which means that your light generative XGenerative design model that you design and create on the web can be opened in the rich client and further developed with solid models that were developed for manufacturing. Both of these videos show how engineering templates that were modeled with our architectural detail designer can be replicated in a model to generate very high level of detail, very high fidelity models that will be used for manufacturing and for life cycle of the building. So we can link directly our simple or our sophisticated but very performative XGenerative design model with a very high level of detail model. With XGenerative design and the 3D Generative Innovator package, you're also able to collaborate fully web on the platform with multiple stakeholders. This is just one scenario, one potential scenario of a workflow where models are coming in, models are being imported onto the platform, they're being shared on a 3D space, tasks are being managed with our collaborative task application. Modeling and design happens on XDesign and XGenerative design. Life cycle is managed. Parts and products are assembled. They're reviewed in 3D Play. They're shared with 3D Swim. They're made and 3D printed on the marketplace. And then they're exported to 3D Drive and shared with external collaborators. All of this is available on the platform. All of this is available with web applications with no installation required. And finally, this application and our entire suite of X apps is available anytime, anywhere, on any device. There's no installation required. You access these applications uh, on the 3D Experience platform, which are computed on a remote server that reduce infrastructure costs for the users and for companies, and increase performance because you're not dependent anymore on your hardware. You're only dependent on your internet connection. So with that, we're going to look a little bit at some of the yeah. With that, we're going to look at some of the recent creations that have been imagined with the X Generative Design application. For last year's Design in the Age of Experience event, we worked with Kengo Kuma to design this pollution absorbing, carbon monoxide reducing installation at the Design in the Age of Experience event for Milan Design Week. This was one of the first times that X Generative Design was put into a production use in a confidential setting, but it allowed the designers to create these magnificent forms with no limits to their creative intentions. This product has been under development for well over 2 years. Back in 2017, we had a hackathon also at the Design in the Age of Experience in Milan for the Milan Design Week. And here we see a couple of examples of the projects that were delivered on that very first X Generative Design prototype. These projects were again modeled entirely with X Generative Design on the 3D Experience platform. Another example of a imaginative dome. We have image mapping capabilities within the application. You can set up relationships, complex relationships between geometry to control driving parameters and control geometry to generate data. And there's really no limit to what you can produce. We've even used this up to the scale of city planning and urban design to generate multiple options for a new city development. Finally, now I'd like to introduce Nicolas Senemo, who's going to give us a live demonstration on how to use X Generative Design to explore our first steps on the platform and show you what the application can really do.
Thank you, Jonathan. So, as a matter of fact, I'm gonna comment a live demo. So we're gonna see together the very first steps to get on board to start using X Generative Design. So there are a few best practices to respect in order to create your first XGen model. So that's why I'm gonna comment over a live demo that we are used to sharing with our clients and partners. So first of all, X Generative Design is a web application, so everything starts on basically your web browser, so Google Chrome in that case. So here I'm accessing my platform, and as you know, everything is dashboard. So here I am on my X Generative Design dashboard. I have a lot of tabs with a lot of X Generative Design models inside them. So to get started, you need to actually get the X Generative Design widget, drag and drop it into your tab to start working. So I'm just expanding the window here. You need obviously to rename your model to be able to find it afterwards. And most important of all, you need to select the right collab space in which you're working in order to be able to share it or just to put all the models in the same collab space for a specific project. So here what he does is creating a Katia product exactly like in the Reach app. So he's creating a product, and inside the product we have a 3D shape. So here you can see the product that has been created and indexed in your database with the right name and the 3D shape. And all the features that you are going to do are going to be stored in the spec tree here. So this is what we call the immersive interface. So this is where the 3D is gonna appear. You've got at the bottom a toolbar that allows you to create points, lines, surfaces, to do more advanced features like join, split, dividing surfaces, things like this, and obviously a view bar. And again, the spec tree, remember that we are working at the 3D shape level. When you create a next generative design model, you are working at the 3D shape level at this point. So here I'm gonna launch the design sequence, which is the visual scripting interface that has just appeared on the right. So just by clicking on design sequence, edit, it launched the what we call the canvas. So at the bottom here, you have a lot of operators that will help you to design your project. So either it's list management operators or geometric features like to create again geometry. But remember that all the features that you have are actually the same as in CATIA. So and obviously they can generate geometry at the same quality as in CATIA. So those are geometries here, surfaces, all the math operators, images, and coloring. So let's get started with the first with the first operator. So the first operation will just be a translation of my origin with the direction of my XY plane. So I am actually going to get my inputs in what we call global variables, which is a list of favorites. So we're gonna see in a bit how you can edit those favorites, but they are very efficient and handy. So here I want to move my origin by my XY plane direction and with a distance of 2 meters. So everybody would expect, if I go back to in the immersive, my point being moved of 2 meter up, right? So let me just hide those planes because we don't really need them at this point. But it's very important to insist saying that it's a unified interface. So there are no boundaries between the design sequence or the immersive. So what the geometry you create in one is automatically displayed and created in the other, and it's a total in sync interface. So here, for example, if I change the name of my geometry, so first point, for example, it will be updated in the immersive. So I could even change the operator in the immersive, and my graph would be updated. So let me just continue working in the immersive interface. So I'm just going to create a circle based on my first point on my XY plane with a radius of 1 meter. And I'm going to redo another one, but as a center, my origin this time. So let me just do this again. Here, circle, origin, plane, and then radius 1 meter. So just notice that I'm actually embedding the parameters inside the boxes. So this limits actually the number of boxes because we want to limit the number of operators because it's really easy to get lost. So next step is to divide my circle by a certain number, and I am actually going to make this number a favorite. So this number that I'm creating and that I'm renaming will be accessible for a further operation. So here my divine number, and here I'm going to divide my second circle, and I'm going to fetch this new number into my favorite list. So here I don't need to type either the same number, or I don't need to connect it in my design sequence. I can just do it directly in the immersive, and everything is kind of synchronized. So at this point, I'm going to create lines between the two sets of points, and you can see the graph is updated while I'm working in the immersive. So this is little by little you can construct, I would say, a graph, a parametric logic without even connecting a single node. And and it's very important to keep the design sequence clean because you will end up with hundreds probably of those boxes, and your best friend at this point will be the automatic layout feature. And you can also create groups, etc. So at this point, and just please notice that I haven't saved my model yet. but though I'm gonna refresh my page, so it's just to show that in case of, for example, a connectivity loss, you can actually recover your model because the model is embedded to the widget. So here I'm just recovering my model, and you will see that I'll get to the last state of my actual to my actual model. So here I'm gonna relaunch my graph. Here I am gonna reorder them a little bit to get everything in place. So notice that we've got again a lot of the information embedded into the features. So they are kind of intelligent feature, and but you can go a little bit further in publishing parameters. So by publishing a parameter like this one, by clicking on the small Wi-Fi signal here, you're actually making this parameter a controller. So a controller is kind of a super parameter that you can actually access directly from the immersive. So here I can change, for example, 10, and everything will update. So it's a way of passing from back and forth from the immersive and the graph. Going a little bit further on this logic of embedding intelligence into the features, I am gonna show you how you can influence outputs and inputs without creating new features. So this as an output of my dividing point feature, I've got a list of points. So I have one list of 10 elements which are points, and I am gonna modify. I'm gonna influence this list with a list management operator because I want to change the list structure, for example. So here I can actually embed a sub-function into the function. So here I'm going to deepen. A deepen is a very important list management operator. There are many, but this one is very important. It increases of one dimension of your list. So meaning that here you can see that now I have 10 lists of one element each. So in this particular case, when you cross product a deepen list and a flatten list, you get what we call a cross product. So it basically computes all possible possibilities, and in the watch you can see how everything that is computed, and it gets you at the end a matrix. So the biggest value of this of the unified interface is that you have this what we call the highlight, the cross highlight, and you can actually see the results directly from the graph highlighting in the immersive interface. So this is very efficient when it comes to work in and to navigate in a complex environment. So here I'm actually going to isolate different elements here one by one. So different elements on different lists, they have nothing to do with each other, but I need to extract them for some reason because this you have a lot of exception in parametric design. So here I'm going to create an assembly, and you can see that he created me the sublist in order to extract me those lines. So here he created me out of those lines a sublist with the right indexes in the first dimension and second. So this is absolutely key in parametric design, working with lists. This is probably the most efficient mean to work with a lot of geometry and when you need to find a hierarchy between elements. So and the best way to manage the list is will be the graph in that case. But once your logic is done, you can actually shift to the immersive interface and start actually working and doing some versions, some optioning directly from the immersive. So here I am gonna change the divide number here directly from the immersive, and you can see that it has updated with the graph being closed. So this is absolutely essential because it shows how on a web browser you can actually do pretty advanced parametric design with good logic behind it, and it also means that you won't be constrained by a device. You can access your model on an iPad, on an iPhone, on a Mac, or on Windows. It doesn't matter. So it's we're actually removing frictions from devices, from workflows in order to enhance design and productivity. So Thank you.
Thank you, Nicolas. It's an exciting application, and you see now the revolutionary aspect of it with the two interfaces. When you're modeling in 3D, it's automatically generating this graph, this design sequence for you, and vice versa. When you're working in the graph, it's automatically generating that application. It's automatically modifying what you've been doing in 3D. So there's one unified model across the multiple user interfaces. So what I'd like to show now are a few resources for those of you who want to grab this application and explore directly. Our first reflex to share training materials with the world is to create a YouTube channel. To create a YouTube channel where we're sharing videos. You can go today now to youtube.com/c/CATIA AEC, where we've posted a number of videos to get you started. There's a video on the first steps in X generative design. There's a video on how to do building massing with X generative design, and another one on collaboration to model a feature wall with X generative design. These are videos that build on top of each other, and I've got 3 examples that show the type of information that you'll learn on X generative design. So these are short versions of the videos that are posted online. This video is the collaborative feature wall video, where we're starting in CATIA on the rich client that you've installed on your machine. We're going to insert a new part into the model and use the CATIA sketcher to create a surface. So right now we're in the sketcher. We're going to make a quick surface. We're going to make a rectangle. We're going to output that profile curve. We're going to also create curves that define the boundaries of our doors. We'll make a surface. We'll split that surface. We'll save that file. And then we'll go to X generative design on the web, search our collaborative space, find that file, find that part, and open it in X generative design. We'll start by making a quick divide. We'll take the boundary curves of those divided elements. We'll offset those curves, and then we'll extrude those curves. We're doing all of this in the 3D immersive environment. At any point then, once we're ready to modify the logic of our model, we can open up the graph. Here I've added a random value operator to produce variation within my model. And then once we've created this model, we can save it, go back to CATIA, do a selective refresh. CATIA has automatically detected a change to this part in the database. It's refreshed the model, and now I can continue my design by modifying the parameters that I defined in X generative design. So for example, we'll change the spacing in the U direction of that surface. We'll change the spacing in the V direction of the surface. And you see that the design sequence is updating and producing this geometry for me. So this is one way of collaborating within a unified master model across different phases and project team members. A second example is how to take a X generative design model that starts in X design into a fabrication level of detail. So we'll start here by making 2 widgets on our dashboard, one X design, so this is your first time seeing X design, and one X generative design. With X design, we'll make a sketch, and this is a CATIA sketch. So when you open this model in the rich client, you'll have a sketch here that you can edit and modify. We'll make a couple of lines that represent that will be extruded as a surface, and then we'll make a couple of points as well because we want to do a spline in X generative design. I'm going to model a rectangle here, and here you see the generative nature of X generative design. When I make one rectangle, it replicates that rectangle everywhere. Now I'm going to add some logic in the model to be able to switch from one surface to the other. So I've defined a parameter that switches the inputs of my model. So I'm acting on one surface or the other, and because the base surface now could be different, I want the rectangles to be the size of the rectangles to be computed automatically. So I added some logic to make sure that the height and width of my panels update based on the input surface. I'm going to open this model in the rich client, and you see that when I switch that surface selector, it still updates. And now I'm going to create a new part inside using the sheet metal design application. So with a sheet metal design application will allow me to make this panel, and it does the calculations for K factor for folding and everything like that. It does the notching based on the machining requirements. It includes an unfold view that I can project into a drawing for manufacturing. And now I'm going to create a CATIA assembly, a curtain wall assembly. So I'll input my X design and X generative design model. I'll input my sheet metal panel, and I assigned the width of this sheet metal panel based on the rectangle sizes from X generative design. I can do an assembly constraint to position my sheet metal panel in place, and do an assembly pattern to replicate that panel across all of the axis systems in my model. Because CATIA is parametric, when I change my input surface, my model will update. And because I linked the size of my sheet metal panel to the size of the rectangle computed in my X generative design model, the size of my panels change too. Extending this a bit further, I'm going to make an imagine and shape surface, which is a subdivision surface, and replace my previous surface with this new subdivision surface. Now you see my assembly pattern is completely updated. And I can continue sculpting my surface, and all of my panels positioning will update and change. This is the final result, and because these are sheet metal panels, I can always go back and show that unfold. And had I included a drawing in this model, I could export all of those drawings to the shop for fabrication. The final example is going to take that one step further. So this video is a building massing video that you'll see on our YouTube channel that will walk you through every step to model this building. Exploring some of the driving parameters through the controllers panel, you see how we can produce variation within the design space of this model. And what we want to do is single out one of these canopies. We're going to build an engineering template, and then we're going to use CATIA KnowledgeWare to instantiate that parametric engineering template across the canopy geometry. So we'll walk you through in X generative design how to take a surface and create a triangle pattern on that surface using a subdivision surface as an input just to test our model. So through list manipulation, we come up with the triangularization pattern. We can control the polylines and change them back and forth, change the orientation back and forth. We have axis systems that will anchor our our engineering templates. And then in CATIA, the rich client, we're going to show you how to model an engineering template from scratch. This is a component, a fixation component that's going to be used to assemble our panels. You see how we create that engineering constraint within our model that positioned our panel. And now we're going to do an assembly pattern within that panel for all of our fixings that are common across all of our panels. Back in the contextual model, we can instantiate those engineering templates into our model using our X generative design triangular grid by running an action. All of this information is on our YouTube channel, so if you want to run through this process, you're capable of learning directly from our videos. The final view of those panels, once they've been instantiated into the contextual master model that was defined in X generative design and rendered with live rendering. So you see with these three examples the breadth and depth of our solutions for CATIA to execute an entire design process from generative model through to construction. And with that, I'd like to thank you for your attention. It's been a whirlwind presentation here covering a lot of topics. It just goes to show the offer that we have with X generative design integrated into the greater AEC portfolio from CATIA on the 3D Experience platform. I think it'd be great to see what kind of questions have been raised during the presentation and how we can and what kind of answers we have to those questions. So, Nicola, do you have any questions for me?
I do, as a matter of fact. So we've already got 5 of them. Pretty interesting. So the first one is, can I edit the design sequence graph in the rich client?
Great question. Great question. Today in 19x, you do not have access to the design sequence in the rich client. You saw that in X generative design, you can open up a model, you can create a model, you can explore design variations by creating that script. But in the rich client, there is we've had technical limitations. We have not exposed that in 19X.
All right. Second question, can I create my own nodes?
That's another great question. In 19X global availability, so that's what's available today, no, you cannot create your own nodes. However, we have planned for an FD release, I believe, in the coming months. Sometime probably in the summer of 2019, you'll be able to capture a grouping of nodes and collapse them into one unique node that can then be shared across your enterprise. And that will be coming soon, and we'll see. We have plans to extend that functionality even further in the future, but more on that in the future.
Thanks. Third one, can I use X generative design to create and modify assemblies?
That's another great question. Today, no, you cannot use X generative design at the assembly level. However, you can reference parameters and geometry across assemblies using traditional CATIA mechanisms. So you saw in one of the videos how we reference global parameters to drive an X generative design model across multiple X generative design models across an assembly, and that's where it stands today. But in the future, chances are, yes, you probably will be able to work at the assembly level with the X generative design.
So nothing prevents you from making assemblies of different XGen models, and you can link them with common parameters.
Absolutely. That's available today.
Okay.
Out of the box.
Thanks. So are there additional X apps and roles planned for the future?
There are. We are expecting to release a portfolio of X roles in the future. X generative design and X design are the first of what will become many, and what's really exciting for me as an architect is how we're going to expand and verticalize X generative design using more traditional building experience modeling techniques and functionality.
Fair enough. Last one, which is probably a question that comes across the mind to a lot of people. How do I get access to this application?
Great question. X generative design, apart from being easily accessible on the 3D Experience platform through any web browser, is available through our dedicated sales channels. If you're a small or medium company, reach out to one of our value-added resellers, our VAR partners, and they will be able to get you access to this application for an evaluation or a paid license. We have a special offer for AEC users and AEC customers that packages up X generative design, X design, all of that into one simple, easy to access package, and that's available through our partners. So go to our website, find a partner near you in your geography, and don't be afraid to reach out to them to get your license.
Perfect. Thank you, Jonathan.
Great. Well, thank you very much for your attention. I hope this has been informative. Please go to our YouTube channel, reach out to your partners, explore X generative design, and give us your feedback. We're very excited to hear how you hear and see how you're using X generative design to expand your creativity and imagine a new world. So thank you very much.